Is time travel possible? This is a question we've all pondered at some point in our lives. Fortunately, scientific progress has brought us to a stage where we can begin to address this age-old query in a more concrete way. In scientific terms, time travel refers to moving between different points in time, much as we might move through different points in space. In theory, this could be achieved by an object or person using a hypothetical device often referred to as a time machine. So, is time travel possible? Without any cliffhangers, the short answer is, traveling forward in time is not only possible, it's inevitable. Traveling back in time, however, is a far more complicated matter. According to Einstein's theory, we live in a four-dimensional space-time, yet the structure of this geometry, particularly the role of the speed of light, appears to prevent backward time travel. Still, one can imagine theoretical shortcuts through space-time, commonly known as wormholes. Visionaries like Stephen Hawking have proposed the chronology protection conjecture, which suggests that the laws of nature will always conspire to forbid backward time travel, ensuring that paradoxes, such as preventing your own birth, cannot occur. This conjecture remains unproven, though. Einstein's special theory of relativity forbids backward time travel, and while we are unsure if his general theory allows for it, most physicists suspect that the universe has built-in safeguards. Physics protects the past. Some theories, especially those stemming from special and general relativity, indicate that certain space-time geometries or specific types of motion might permit travel into the past. This involves the concept of closed time-like curves, loops in space-time, where an object could theoretically return to an earlier point in its own history. While solutions to Einstein's equations predict such curves, their physical plausibility remains uncertain. Many scientists believe backward time travel is extremely unlikely, largely due to the causality problems it creates. The classic example is the grandfather paradox. If you traveled into the past and prevented your grandparents from meeting, how would you ever be born to travel back in time in the first place? This kind of paradox arises whenever altering past events is considered possible. One proposed resolution is that a time traveler may only do what has already happened, never what hasn't. If backward time travel is indeed impossible, what about traveling forward in time? Physicists are quite confident that moving into the future, at least at a different rate than someone else, is not only possible, but happens routinely at extremely high speeds. Particles accelerated to near light speed in particle accelerators experience time dilation, traveling forward relative to the rest of us. Even astronauts, due to traveling at high speeds and experiencing different gravitational fields, age slightly more slowly than people on Earth. Thus, upon returning, they have effectively traveled into the future compared to those who stayed behind. In 1927, British astrophysicist Arthur Eddington introduced the idea of the arrow of time, highlighting time's apparent one-way flow. Thermodynamics, particularly the second law, which states that entropy tends to increase, helps us understand the universe's evolution and the apparent unidirectional nature of time's flow. Yet, some peculiar solutions to Einstein's field equations in general relativity suggest that under extraordinary conditions, faster-than-light travel or traversable wormholes might enable backward time travel. The sticking point is that when we incorporate quantum effects into general relativity, these loopholes tend to vanish, indicating that stable, usable wormholes for time travel may not exist. Wormholes, if they exist, are allowed within the mathematics of Einstein's theory of general relativity. They're theoretical shortcuts through space-time. However, when you add quantum mechanics to the picture, these wormholes appear inherently unstable. They would likely collapse if someone tried to pass through them, thus preventing their use as time machines. Still, researchers are actively exploring concepts like the EPR correspondence, linking wormholes and quantum entanglement to better understand the fabric of spacetime and information transfer at cosmic scales. While constructing a traversable wormhole time machine remains purely hypothetical, the idea captures our imagination. It's thought that if such wormholes existed and could be stabilized using hypothetical exotic matter with negative energy density, a highly advanced civilization, perhaps a Type 3 civilization on the Kardashev scale, might employ them for intergalactic travel or even time travel. But this remains firmly in the realm of speculation. As we continue to push the boundaries of physics and explore quantum gravity, we may one day have definitive answers. For now, time travel into the future is a given. In fact, it's happening all around us in subtle ways, while backward time travel remains a captivating but likely forbidden dream. Thanks for watching. If you enjoyed this video, support our channel by subscribing and ringing the notification bell so you never miss another exploration of topics like this.